Cambridge AS Physics. This question is about electromotive force EMF, internal resistance and terminal potential difference. So let me explain to you first of all what is internal resistance. You can see inside this dotted box, if you look at this one, this is dotted box. So inside this dotted box we have battery. You can see this is E, this is representing the EMF, and also we have small r. This is the internal resistance. And so R we use for internal resistance. So you need to be quite familiar with this symbol. So small r often we use for internal resistance. And this resistance is also called source resistance because this is the resistance of battery itself. And the second thing we need to understand is terminal potential difference. So this is what we call is VT, and this is terminal PD or terminal potential difference. So what exactly is terminal potential difference? So we can simply draw this picture of the battery like this. This is if we draw like this. So you can see now it more look like a battery now. So you will simply say that this is positive terminal of the battery and this is the negative terminal of the battery. So if now we attach a voltmeter across these two terminals, so let's say we attach voltmeter like this here. And so this voltmeter will tell us terminal potential difference. We can also find terminal potential difference by attaching a voltmeter across this load resistor, or in this case also this is external resistor. Load resistance actually is external resistance. So we call this is load resistance. In this case, we just have one resistor, so we can also call this is load resistor. So what we will read from this voltmeter, that is also equal to VT. Now, next thing we need to understand how E, R, and V, they are linked together, how they are connected with each other. So that is just based on conservation of energy principle. So if we have understanding of conservation of energy, so simply we can write the equation. So this is based on conservation of energy. Means the electrical energy per unit charge has to be equal to the terminal potential difference plus it also has to be equal to the voltage lost inside battery. Okay, this is very important equation to answer questions about terminal potential difference and internal resistance. Now let's try to answer this question now. The question is asking us current in the circuit. First of all, it is given to us, and the terminal potential difference across the variable resistor is also given, that is equal to V. The question is asking us explain in terms of energy why V is less than E. So simply we can understand from this equation, if we look at this one, we will simply say that E has to be greater than Vt because some of the energy has been dissipated in the internal resistance. So if we have this understanding, and this has only 1 mark, and we can answer with confidence this question. So let's try to answer now. Okay, so this is how you can answer this one. You can simply say energy is dissipated in the internal resistance because E is equal to capital V plus IR, and IR is energy loss in the battery per unit charge. You can also write down here per unit charge. Okay, so the next question is asking state an equation relating E, I, R, and V. Means in our answer, we must have these four variables. So it's a quite straightforward question. It is simply based on this equation. So we can answer this question now. So for this question, simply you need to write this formula, this equation relating E, V, I, and R. For part C, we need to understand the relationship between EMF and internal resistance. So we have discussed that E is equal to terminal potential difference plus I times R. Now, if we rearrange this one, we can simply say that Vt is equal to E minus IR. We can also rearrange little in a better way. We can say this is minus R times I plus E. And also we understand that the straight line equation that is equal to y is equal to mx plus c. Now from here, if we compare these two, we will say that on y-axis we have terminal potential difference, and the slope of or the gradient that is equal to minus r, and this is x. We can also from here, and this is something important one we need to understand. C in this case is the y-intercept. So C is y-intercept. And we can see here, this is x-axis, I is on the x-axis. So we need to find the y-intercept. So y-intercept simply means this point is y-intercept. So this is the E. Now let's try to answer this question now. Question is simply asking us, we have to find the EMF, and that is equal to 2.8 volt. So you can see from here, so EMF is equal to 2.8 volts. So this is our answer for C1. Now, the next question is asking you, calculate the internal resistance. So the internal resistance is equal to M. Means in this case is equal to gradient of this line. So simply we can find the gradient. So we can find the gradient. You can see this is E minus V, V at this point. So we can find the V at this point. So V at this point is equal to 0.7, and this is the EMF. And current we can also find. Current here is 0 and current here is 1.5. If we draw this line down, so this is 1.5. Just plug in value and we will get value of internal resistance. For part D, first thing we need to understand is the potential difference across variable resistor is given to us, that is equal to 2.1 volts. And question is asking us, use figure 6.2, means use this figure and calculate resistance R. So first thing we need to understand, the resistance R is simply is equal to V over I, means if we have the potential difference across resistor and if we have the value of current, we can simply find resistance. So in this case, potential difference is equal to 2.1. It means we have to read 2.1 from y-axis, and then we can find the value of current when potential difference across variable resistor is equal to 2.1 volts. So this is how we can answer. So you can see here I have drawn this circuit for you. So here this is the variable resistor, and when potential difference across this variable resistor, that is equal to 2.1, from the graph we can see current is equal to 0.5 amps. So as you can see here is equal to 0.5 amps. So just divide potential difference by current and we will get value of resistance. So in this case, resistance is equal to 4.2 ohms. Next thing, let's move on to second part now. In second part, we need to calculate the number of conduction electrons in a time of 1.0 second. So I, we need to understand, is equal to Q over T, and Q, we can write Q is the total charge, and Q can be written in form of NE. N here is the number of electrons. N is number of electrons, so we can write down, and E is the charge on single electron. So we need to find N, so we can rearrange this one in this form. Then what we need to do, just plug in values. Data is given to us, we just plug in and we will get number of electrons. So in this case, number of electrons are equal to this. Let's go to next one, the last part. So in this part, we need to calculate time taken when energy become equal to 1.6 kilojoules. So we need to understand, first of all, the initial amount of energy stored in the battery, that is equal to 9.2 kilojoules. So this is 9.2 kilojoules, and it become 1.6 kilojoules. So we need to understand how long it will take, means the time taken we need to find. So how we can find out? So we need to understand that delta E is equal to P times time, and power of the battery in this case is equal to EI. If we multiply with time, we will get energy. So this is delta E, and then we can find value of T. So here we can see energy, we have this basic formula, and then we just plug in values, and if we just solve this one, we will get this answer, and this is value of time taken, and this is in seconds. That's all for this question and also for today's video, and see you next time.